Okay, number 3 on the practice exercises on page 132. Again, go ahead and draw your blank PFT box and fill in the values that are given to you. The first one is total lung capacity is 6,000 milliliters, so we can write 6,000 in the total lung capacity box. IRV is 3,000, so we can put the 3,000 milliliters in our IRV box. Vital capacity is 4,700, so we can put that in the vital capacity box. And the last one we're given is FRC of 2,400, so we'll add that to the box down here. All right, so the first one it's asking us to get is ERV, and we don't have enough information for ERV at this moment. The next one is residual volume, and we can find that one by taking our total lung capacity of 6,000 and subtract off our 4,700, and that leaves us with a residual volume of 1,300 milliliters. So we can put 1,300 in this box here and 1,300 over here. Let's see, our inspiratory capacity. We can't find, oh yeah, we can find that one. So for inspiratory capacity, let's find our expiratory reserve volume next. That's the expiratory reserve volume, this box here. So for expiratory reserve volume, we can take our FRC of 2,400 and subtract off our residual volume of 1,300, and we are then left with 1,100. And again, that's in milliliters. So next we can find our tidal volume. So for our tidal volume, we're going to take our total lung capacity and subtract off our IRV, ERV, and residual volume. So if we take 6,000 minus 3,000 minus 1,100 minus 1,300, we're left with a tidal volume of 600 milliliters. And then we can go ahead and find our inspiratory capacity. We'll take our 3,000 on the IRV plus our tidal volume of 600, and that gives us 3,600. And we can go ahead and check our work again. You can take all 4 of the volumes and add them together. So 3,000 plus 600 plus 1,100 plus 1,300, and you get 6,000, which is correct for the total lung capacity. You can also take your inspiratory capacity of 3,600 plus your FRC of 2,400, and you again get 6,000, which is the correct total lung capacity. And then the third way you can check your math is you take your vital capacity of 4,700 and add in your residual volume of 1,300. And again, you get 6,000 milliliters for total lung capacity. So go ahead and pause the video right now and look at number 10 and go ahead and do that one on your own, and then I will give you the answers when you're done. So go ahead and pause that. When you're ready to come back, I'll have the answers for you. So number 10, if you've completed that, you should get an FRC of 2,600 milliliters, an IRV of 3,600 milliliters, a residual volume of 1,300 milliliters, and a vital capacity of 5,400 milliliters. Right. You can do the other exercises on page 131 through 136 if you want some more problems with using the PFT box. All right, moving on with Unit 6. All lung volumes and capacities are based on 3 main things. So the 3 that you'll want to remember are age, height, and sex. So how tall they are, how old they are, and if they're male or female. So those are kind of the 3 things that we log into the computer. And then based on those values, the computer gives us predicted values for that particular patient. There are some other ways predicted values can vary, and that can be from race, ethnic background, socioeconomic factors, environmental exposures, occupation, and place of residence, either urban or rural. When performing PFTs, the adult patient will be tested performing while sitting or standing. Either one is fine, but if you're doing a pediatric PFT, they do need to be performed while the child is standing. For tidal volume, the patient should breathe normally into the spirometer, and we measure volume and count the rate for 1 minute after the patient has established a stable pattern, and this will give us a minute volume. And then at the end of 1 minute, tidal volume is calculated by taking your minute volume divided by your respiratory rate. So if you have that patient breathing into either a Wright's respirometer, which we'll talk about, which is just a handheld spirometer, or if they're breathing into a digital spirometer, you will count their respiratory rate for 1 minute, and then whatever you get on the spirometer will be their minute volume. And then you're going to take the minute volume divided by your respiratory rate to get your tidal volume. So that is the equation that you learned in first semester. It's sometimes referred to as using the triangle. Hopefully that looks familiar to you. We use a Wright's respirometer. We can do this at the bedside of the patient. It's just a handheld respirometer, and we will get that out when we get back into the lab at NICC. Looks like I'm getting another error, so I'll do a couple more minutes and then I'll have to probably stop. But for the Wright's respirometer, if the patient blows into it at less than 3 liters per minute, they'll get an inaccurate reading. If they breathe into it more than 300 liters per minute, or if they're doing a forced vital capacity, they will break the veins on the respirometer. There is a one-way valve that prevents patient contamination between patients, and it does need to be autoclaved in between patients for sterilization. So just the difference between a forced vital capacity, you can do a slow vital capacity on a Wright's respirometer. And again, remember, the vital capacity is where the patient takes a deep breath in and then they exhale as much air as they possibly can. In a forced vital capacity, they exhale that air very fast and forcefully. With a Wright's respirometer, you cannot do that because you'll break it, but you can do a slow vital capacity. So you could have the patient take a deep breath in and then blow all their air out, but do it in a slow manner. You may also hear a Wright's respirometer referred to as a vane respirometer. And this is kind of a picture of what it looks like. And you can see a picture in your PowerPoints in your mod. And again, we will get that out in the lab when we are able to get back to campus. So I'm going to stop the video here because I keep getting this error. And I will try to get more videos put on here. Otherwise, we will start the Zoom on tomorrow, which is April 15th. So if you're able to join, we'll do that during normal class time at 12:30. These are just supplemental videos that you can watch if you're unable to do those Zoom sessions, but we will also record the Zoom sessions. So I would encourage you to watch both if you're able to. Again, if you have any questions, let me know. Thank you.